This video is about the last three MathXL problems, number 5, 6, and 7. I just thought that I would pull one up. Hopefully it's not the exact same one as yours, because I would like you to do one on your own. So if it is the exact same one as yours, please go out of it and get another one so that you can practice these problems. Number 5, the first thing it says, the height, which is in feet, of an object moving vertically is given by s equals negative 16t squared plus 48t plus 36, where t is in seconds. Find the object's velocity at t equals 2, its maximum height and when it occurs, and its velocity when s equals 0. So the first thing they're asking for is the velocity of the object at t equals 2 seconds. So we would have to take the derivative of the position s, and that's going to give us negative 32t plus 48, and they want the velocity at 2, so that's going to be negative 32 times 2 plus 48, negative 64 plus 48, negative 16 feet per second. So that is answering that first question. The second question, they want its maximum height and when it occurs. If an object is moving vertically, it is going to stop when it hits its maximum height, and that's where the velocity is 0. So to find the maximum height, I wanted to find the time when it was happening. I set my velocity equal to 0. And I moved my 32 over, made it positive. I don't know why I just wrote negative there. Positive 32t equals 48, and then divide by 32 on both sides. And my t is equal to 3/2. Those were both divisible by 16. And this would be 3/2 seconds. So it's occurring at 3/2 seconds, and to find the maximum height, we're going to calculate s of 3/2. So that's going to be negative 16 times 3/2 squared plus 48 times 3/2 plus 36. And I just put that in my calculator, and it gave me 72. So this maximum height is 72 feet. So that was your second question. The third question is, find the velocity when s equals 0. So we are going to set s equal to 0. I know you could probably divide by 2, and this may be divisible by something. Actually, it's not going to be, because I just glanced at my answer. So what I did on here is I used the Pythagorean theorem, and I said, this was my A, that's my B, that's my C, and of course, I said T equals negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So negative 48 plus or minus the square root of, I put 48 squared in my calculator, and then I noticed a negative times a positive, that's a positive. And then I took 4 times 16 times 36, and I got 2304 divided by negative 32. Then I split these up. And I put this square root in my calculator and it reduced it for me, 48 root 2. Now if I'm dividing by a negative 32 and this says plus or minus, the plus times the negative is the minus times the negative is the plus. So I don't need to worry about the plus or minus, or the minus down here. I went in my calculator and put 48 divided by 32. It reduced it to 3/2. So I said 3/2 plus 3 root 2 over 2 is approximately 3.62. And 3/2 minus 3 root 2 over 2 is approximately negative 0.62. We don't deal with negative time. And our T stood for time. And remember, we're finding the velocity when the S is 0. This is the time when S is 0. Okay, if I want the velocity when S is 0, I need the velocity at this time. So this is going to be negative 32 times 3.62. And I kind of want to recommend that you put the exact value in just so you're rounding correctly. But I must admit that I didn't this time and it did not give me an error. But typically you would want to put and find the velocity at 3/2 plus 3 root 2 over 2. And put that in your calculator, 3/2 plus 3 root 2 over 2 plus 48. Because typically you might have a rounding issue. Like if you know that you did the problem right and it's not accepting negative 67.84, it might be negative 67.85, if you put the exact values in. So please pay attention to that when you are working these problems. But we have just answered all the questions for problem number 5. Now let's go to problem number 6. And when I pulled up, just a random set of problems up, this is my number 6. A hunter is at a point along a riverbank. He wants to get to his cabin, located 3 miles north and 9 miles west. He can travel 5 miles per hour along the river, but only 3 miles per hour on the rocky land. How far upriver should he go in order to reach his cabin in minimum time? And so the picture of this looks like this. Here's the riverbank. Here's the guy. He's 9 miles this way, 3 miles this way from his cabin here. What he's going to, so this is 9, that's 3. What he's going to do is he's going to travel, to a certain point along the riverbed, and then he's going to go through the rocky land to get to his cabin. And so we have to figure out what's going to minimize his time. So we need to write a time equation. And they actually said how far up the river should he go. This is where the man starts. So that's the man. That's his starting point. So they're actually asking for this x value. So that would make this 9 minus x. And I'm going to call this D, and that's the distance along the rocky land, okay, to get to his cabin. So he's basically, moving this way to a certain point here, and then he starts moving this way to get to his cabin. We want to minimize time. First thing I'm going to do is write an equation for this triangle right here. And I can see that my d squared equals 3 squared plus 9 minus x squared. So d squared equals 9 plus, this would be 81 minus 18x plus x squared. So d squared equals 90 minus 18x plus x squared. And if I square root both sides, I have my d. So d is the square root of 90 minus 18x plus x squared. So basically, he's going, x is going to be his distance along the river, and d is going to be his distance along the rocky land. And we all know that distance equals rate times time. So the distance along the river is the rate along the river times the time along the river. And if I want time, I'm going to take distance along the river and divide it by rate along the river. And that's going to give me my time. So the distance along the river we said was x, and the rate along the river is 5. So that's your time along the river. And then we've got the distance along the land is the rate along the land times the time along the land. So the distance along the land divided by the rate along the land is going to get my time along the land. And we said that the distance along the land is d divided by, it says up there in the problem that the rate along the land is 3. So that's going to give you the time along the land. So since we're trying to minimize time, our time equation is going to be the time along the river plus the time along the land. Okay, this is the equation that we want to minimize, right? We want to minimize this big T because that's our total time. We don't want 3 unknowns, so we're going to take this d in terms of x, and we're going to put it in, and we'll have an equation that has all x's. So t equals, this is x over 5 plus the square root of 90 minus 18x plus x squared divided by 3. That's what we're going to take the derivative of to minimize. So if I take t prime of x, this is going to be 1/5 plus, because that's a linear function, so just 1/5 would be its coefficient. Now this is like 1/3 times that square root. So I'm going to look at it as this whole thing to the 1/2 power, and when I take the derivative, I'm going to bring the 1/2 down times 90 minus 18x plus x squared to the negative 1/2 times the derivative of that. So now our derivative is 1/5 plus 1/6 times negative 18 plus 2x, and then divided by the square root of 90 minus 18x plus x squared. The reason I kept the 1/6 up there is because I'm going to go ahead and distribute it right there. I could have put the 6 down here, but I'm going to go ahead and distribute it, and then I'm going to add those two together. So this becomes 1/5 plus, this is going to be negative 3, because 1/6 times negative 18 is negative 3. And then this is going to be plus 1/3 x divided by the square root of 90 minus 18x plus x squared. We want to set this equal to 0, so we need this to be one fraction. So our common denominator is 5 times the square root of 90 minus 18x plus x squared. So you're going to want this 1/5 to get multiplied by square root of 90 minus 18x squared plus x, or 18x plus x squared, right, over itself. That's going to give you square root of 90 minus 18x plus x squared. And then this one just needs to be multiplied by 5 over 5. So we just need 5 over 5 to get that one to have the same denominator. So when I distribute the 5, this is going to be minus 15 plus 5/3 x. And this is what we're going to set equal to 0. Now, that is a really terrible derivative. On a situation like this, I would go to my calculator. So I'm going to take us to Desmos. I already put this into the calculator. If you look, I've got the square root of 90 minus 18x plus x squared minus 15 plus 5/3 x over 5 times that. And it gave me this graph that has a 0. Remember, we're looking for where it's 0. And on the Desmos calculator, if you put your finger on that, it gives you the 0. That's how you do it. I didn't know how to do it, but that's what I Googled, and it said just to put your finger on it. I said, okay. So 6.75 is the 0. Notice it goes from negative to positive. That's a minimum. Do you see how the derivative is, the derivative is below the x-axis, then it goes to above the x-axis. So that is your minimum, because you're looking at the derivative there. So let's go back to our notes here. And so we know that x equals 6.75 is going to be what makes your derivative 0, where t prime equals 0. Okay, and they said on this thing that they wanted you to round to the 10th place. So I would have made that 6.8. And that would have been, I think, miles, right? Miles. So they think that he should walk 6.8 miles along the riverbed to minimize his time, 6.8 miles here, and then the rest of the way to the cabin. We could figure out what that was, but they only asked for the 6.8, so I'm not gonna worry about any of the rest of it. And we did that because this nasty derivative, we had to do our calculator, right? We had to use our calculator to make that, to find the 0 of that. That would have been difficult to find the 0 of, although you would have, set it, the numerator equal to 0, okay? And now we're going to move to the last problem from Math Excel. Number 7. And the one that I chose was find the dimensions and volume of the right circular cylinder of maximum volume inscribed in a sphere. So we've got a sphere, okay? Always draw the sphere first if that's the outside figure, because it's too hard to draw the cylinder and then try and put it in a sphere, because it's very important that you draw this correctly. You're going to put your cylinder in like that because it's inscribed in there. So, it's something like that. So you draw the circle and then, draw like I just did there. Now imagine that the height of your cylinder goes from here to here. That's your H. That's the height of your cylinder. And the radius of your cylinder goes from here to here. Now I want you to imagine, because remember that this is a sphere, so it's three-dimensional here and coming out of the page, but right in the middle is going to be where half the height is, so that breaks that height in half. You can draw a radius to this corner of your inscribed cylinder. This is going to be your radius of your sphere, 45 centimeters. So you're trying to maximize the volume of the right circular cylinder. So the volume equation that you need is the pi r squared times the height, because you're trying to maximize that volume, not the volume of the sphere, okay? So whatever it is you're trying to maximize, that's the equation that we're looking at. We need a constraint equation because right now we, oops, I put an extra S in there. We need a constraint equation because right now we have V, R, and H all unknown. We can only have two unknowns on optimization problems, but usually they give you a relationship. Here's our relationship, this right triangle here. That's the relationship that we're going to get the constraint from. We know that 45 squared is equal to r squared plus, and now be careful here, because from here to here, this distance right here is 1/2 h. So this would be 1/2 h squared. And if you square that 45, you get 2025. And this is going to be h squared over 4. Now, I could solve this constraint for h, but look, it has an r squared, and I need an r squared. So let's go ahead and just solve this for r squared. So I'm going to subtract h squared over 4 from both sides. And then this is what I can put in for r squared. It's just going to make it a little bit easier because I have to put my constraint into my volume because I needed to get rid of one of my unknowns. And this is pi r squared times h still. So now I want to clean this up before I take the derivative. So I'm definitely distributing the h to both of these terms, but I'm also distributing the pi to both of these terms. So this is going to become 2025 pi times h minus, this is going to become pi over 4 h cubed. And now we want to take the derivative of this because this is what we're trying to maximize. So this is going to be 2025 pi. That's your coefficient of h. I'm going to bring the 3 down times the negative pi over 4, giving me negative 3 pi over 4 h squared. And now I'm going to set this equal to 0. And of course, I'm going to move my negative 1 over. And I multiply by 4. And that gave me, when I multiplied that, 8100 pi. Divide by 3 pi on both sides. And h squared became 2700. And when I took the square root of 2700, I got 30 root 3. So when you're working this problem, it asks for the dimensions and the volume. So right now, and it asks you to round it to the nearest hundredth. So I would have taken that 30 root 3 and got myself a decimal and rounded to the nearest hundredth, and I would have gotten 51.96, and that's centimeters. Then I would have taken my r squared equation, and I think I'm going to go up here. My r squared equation was 2025 minus h squared over 4. So my r is going to be the square root of 2025 minus, and now remember, you don't want to use the decimal. You want to use the exact value. If you use the decimal, it's probably not going to work out correctly. So this became square root of 2025 minus 2700 over 4. And this became r equals 15 root 6. So that's your exact answer, but they want it in the Math Excel, they want you to round it to the nearest hundredth. And so I did that, 36.74 centimeters. So there's your other dimension, because really the cylinder is only going to have radius and height as your dimensions. So those are your two dimensions that it would be asking for. And the last thing it asks for is that actual volume. So guys, I would go ahead and use your exact values. Okay, so we got r to be 15 times the square root of 6. So this is going to be pi r squared times the height, which was 30 root 3. And when you put that into your calculator, hopefully, I don't know if everyone's does, but gives you the exact answer of 40,500 pi times the square root of 3. And then the Math Excel was asking for the answer rounded to the nearest hundredth. And so the volume rounded to the nearest hundredth is 220,376.62 cubic centimeters.